Example 3. Put a star beside it. These kind of questions come up a lot. The point -1, -4 is a terminal point of an angle in standard position. A terminal point is a point that happens to be on the terminal arm. Determine the exact values of all the 6 trig ratios for theta. So I put a star because the starting point of this is typical in a lot of trig questions you're going to answer. And I'm going to tell you a secret trig strategy for trigonometry. The secret trig strategy for trigonometry is draw a triangle. I know. Right? Don't let your friends know. Keep your math skills above them, right? No. So what we're going to do is we're going to say, well, where is -1, -4? Well, -1, -4 would be going 1 to the left, and then 1, 2, 3, 4 down. That point is right here. -1, -4. If that's on the terminal arm, I can draw back to my origin. Here's the terminal arm that would keep going. It goes through the point -1, -4. You have to draw a triangle. But I'm going to tell you there's going to be temptation in these questions. You see this point, and you are going to be tempted to go to the right because that draws you the triangle the fastest. But that will be wrong. When drawing the triangle, you always, here's the angle theta, by the way. This is the angle theta. This is my reference angle. And the triangle that you draw must go back to your nearest x-axis so that it includes the very important reference angle. Wow. I'm having trouble drawing straight up and down, aren't I? That's a little bit. Okay, imagine that straight up and down. Can you see yourself being tempted to go straight across and make the triangle? Absolutely. It's like, oh, it's closer. It's tempting, but wrong. Okay, so we have to include our reference angle, giving us a not so perfect, but imaginative perfect 90 degrees right there. And in this triangle, you know some lengths. Because you know the point, -1, -4. How long is this side? How long is this side? This side has to be 1 unit long. You went down 4. This side has to be 4 units down. So we already know 2 sides of this triangle. In fact, you are going to get so good at a squared plus b squared equals c squared in your head. You need to show no work for this. You can just write the answer. Square root of 17. Can you do the a squared plus b squared equals c squared square root at the same time and get 16 plus 1 is 17 and get that square root right away? So you're going to get really good at a squared plus b squared equals c squared because you'll be able to almost always draw a triangle, almost always able to label 2 sides, and then you can do a squared plus b squared equals c squared to find the other side. Now, once we have that triangle, this question's asking us to determine the exact values, means no calculators are necessary. Don't have to go to decimals, don't have to round. An exact value is not rounded. You leave square roots if you have them. You leave pi if it's in the answer. And so if we want to find sine of theta, cos of theta, tan of theta, and then the reciprocal ones as well, cosecant of theta, secant of theta, and cotangent of theta, and figure out what each of these are equal to. Well, sine, cos, and tan, you already know from SOHCAHTOA. Sine is what over what? Opposite over hypotenuse. So I look at my reference angle, and on my reference angle, opposite over hypotenuse would be 4 over root 17. But I am in quadrant 3. Sine has to be negative in quadrant 3. So I make sure that I add a negative sign there. Cosine adjacent over hypotenuse would be 1 over root 17. Cos is negative in quadrant 3.
Do you not have to rationalize the?
Well, that is a beautiful question. Question is, we have a square root on the bottom. In grade 11, you were never allowed to leave square roots on the bottom. You always had to rationalize the denominator. I have some good news in grade 12. Okay? In grade 12, they assume you are brilliant grade 11 students. And they assume you know how to rationalize the denominator, so they do not require it. You can leave square roots on the bottom in grade 12. They also assume you know how to simplify fractions. So if your final answer was 16 over 10, you can leave it as 16 over 10. You do not have to reduce it to lowest terms of 8 over 5. Very nice. You can still reduce it if you want to, but if you make a mistake, they'll take off a half a mark. So it kind of makes sense not to reduce things if you don't have to. Okay? Where do they check to see if you still know how to do this? If this was a multiple choice question, it would be rationalized, and you would have to make sure you knew how to do that. All right, we're having computer fun. So for tan opposite over adjacent would be 4 over 1, which is just 4, but you could leave it as 4 over 1, and tan is positive according to your CAST rule. The reason it's nice not to rationalize the denominators is, okay, cosecant is 1 over sine. I'm going to first do it the long way, and I'm going to show you a shortcut, okay? Cosecant of theta, wow, I forgot a C. Cosecant of theta is 1 over sine of theta. And since sine of theta is equal to negative 4 over root 17, this is what cosecant of theta is equal to. But in grade 12, they do not let you have complex fractions. Complex fractions are fractions inside of fractions. You would have to simplify. How do you divide by a fraction? You multiply by the reciprocal. So if I multiplied by the reciprocal, I would get 1 times root 17 over negative 4, and this is the shortcut. Notice the answer just got flipped? So the shortcut is take each of these and just flip them. And you have your answers very quickly. Okay, we'll leave question 4 for tomorrow. You can circle question 8.